Good morning, good afternoon, and good evening, everybody. I'm delighted to be here. So thanks for having me at the Blockchain. It was the best conference, and thanks to Alex for inviting me here. My name is Robert Chu, and I founded a startup company called Emblema a few months ago. And prior to this, I spent 16 years at IBM in different positions in software and services. And most recently, I spent 10 years at a company called IMS Health in healthcare, which is the world leader in the healthcare data services. And my last position was to run the technology division at IMS Health, which really were the software and software as a services SaaS solutions for the company. And I decided to create the startup Emblema, which theme is to apply blockchain in the healthcare industry. Now, I think the reasons why blockchain and healthcare are compatible or a good fit, I think are pretty well documented. Just to summarize those a little bit, I think the first thing is obviously the data integrity properties. The encryption of blockchain is very good for medical records and health data, which is obviously very sensitive data, which are subject to privacy laws like the HIPAA regulation in the United States. So that's very one good thing. The other very good thing is that the distributed aspect of the blockchain architecture, the different nodes out there, is actually very consistent with the reality of today's medical record landscape, which is, it's very fragmented and dispersed. And a given patient, with each one of its encounters, different hospitals, emergency care, primary care centers, you have bits and pieces of your medical records all over the place. And it's very hard today, if not impossible, to reconcile this, to chain this into a meaningful medical history. So I think that's also a very good, interesting property that blockchain can help solve. But I think beyond the technical, if you want, the technical fit, I think there's probably a deeper reason for trying to apply blockchain to healthcare, in the sense that healthcare is very unique, because this is pretty much the only industry where the patient is not really the payer. In many countries, at least developed countries, the payer is the government, it's taxpayers' money if you want, or it's your employer. And therefore, because the consumer, the patient as the consumer of healthcare services is not very empowered and doesn't really have a voice. And he accepts restrictions on the healthcare services he's entitled to receive. You are bound to a healthcare network. If you go outside, then you have to pay for it. You're also restricted in terms of number of encounters. Sometimes you can have each year. The type of prescription drugs you can have, most of the time generics, because it's cheaper. And therefore, patient kind of accept, well, because I'm not really paying for it at the end of the day. Well, I'm gonna get what I get, and that's it, right? And I think one of the and that's very unique to the healthcare industry, because in other industries, the consumer pays for it, and the consumer really has a voice. So patient in the healthcare industry do not really have a voice. And I think one of the dimension where it's particularly staggering, actually, where we have this kind of imbalance of power between the patient and the system, is what I call the inequality of information. And it's very simple. How it works is that when you go see your doctor, he has information on your health that you do not have. Okay, he has all your medical records, your test results, your condition, your disease, at which stage it is. And he has obviously several treatment options. And what happens at the end, he says, well, look, we're going to go for this, and bye-bye. And then, see you next time. And the reason the patient cannot really discuss is that, well, I don't have information, to be able to kind of say, well, is there anything else we can do? And what does this mean exactly? And, what are my choices? And I think this inequality of information is a huge problem, because as, each one of us as a patient, we need to take care of our most important asset, which is our health, right? And to do this and to understand fully what options we have, we need information. right? We need information to make the right decision. And I think where blockchain can really help, so beyond the technical fit that we discussed earlier, where blockchain can really help is to empower the patient and to break this imbalance of power between the patient and the healthcare system, and really reposition the patient into a much more comfortable seat and really have a voice, in terms of receiving health. And I think what blockchain can help specifically is breaking this inequality information issue that I just described. So let me now share my screen. So I'm going to be jumping a little bit between the presentation, and also just before I start the presentation, we managed, and we're fortunate enough to to have developed a working prototype. It's really a pre-alpha type of system called Patient Truth, and what it does is precisely chains back given patients different fragmented medical records across the health systems, and recreates meaningful information, which we call the medical history, for the doctor, for the patient, for maybe other healthcare stakeholders to make the best treatment decision. So that's what we've done. And because we have a working prototype, I'm also going to show you some code and things like that, so that you can kind of better understand how we did this. Okay, so I'm going to be jumping around with several windows. Bear with me. I'm going to try to make this as fluid as possible, but we'll see what happens. Okay, so let me now go into a few slides, and then I think we will have to leave enough time, well, as possible, a lot of time for questions and answers, and of course, welcome any feedback, which will be very valuable for us. Okay, so jumping into the presentation, as I said, right, the mission, what we're trying to do here is really to empower us as a patient, to break this imbalance in the system, and using blockchain as really the equalizing technology. Blockchain is really seen as the most democratic technology out there, because it gets rid of all the middlemen and rules you don't want to be subject to. And I think because of this imbalance of power and information inequality gap, I think definitely, again, it's worth trying something, and that's what precisely we did. So the solution that we're building right now, which has reached the stage of a working prototype, is called Patient Truth. And what it does here is pretty simple. You can see here, if you're this patient, you're this beautiful person here, you're going to have dispersed medical records across, if you went to the doctor office several times, hospitals and emergency centers, for example, here. And what we do is we retrieve those medical records using a standard called HL7. This is a healthcare data interoperability standard that's out there. We're going to ingest this into a blockchain, right? So the ingestion is made through decentralized nodes, right, the blockchain architecture. And then we reconstruct within the blockchain a meaningful medical history. And you can see typically, most important information like allergies, medications, problems, procedures being sorted, in a chronological way, and with different categories here, so that you have in control all of your medical history. And you can share it with, of course, whoever you want, because the data is yours. It's legally yours, actually, in most countries, but practically you can't access it. So it provides you this, this basis of discussion, and really provides you also this ability to have a meaningful discussion with your healthcare provider. Now, the thing in healthcare is that it's a heavy regulated industry for good reasons, because you got to be very careful, right? So there's lots of regulation around drug approvals, medical device approvals, because a drug cures, but it can also kill, right? And then specifically to healthcare technology, there's all sets of regulation around data privacy, data protection, data integrity, data security, whether you go into the States or in Asia or in Europe. I'll comment a little bit more in terms of the HIPAA. This is a very complex set of regulation. If you read the full guidelines and text and regulations, over 10,000 pages. It's not always consistent, so you got to make some calls sometimes. And you do have similar, regulation in Europe. It's called this directive 95/46 EC, which is going to be the GPDR, very soon. And obviously, it's a prerequisite, right? Anybody who does healthcare technology and handling what is called, PHI, protected health information, needs to comply fully to all these regulations. So that's obviously, something we do, and it comes at a huge cost because it's very resource intensive and quite complex and quite comprehensive. And I'll comment some more around it. Well, actually, I'm going to comment right now. So just to give you a flavor, we're not going to go into detail because this is not a HIPAA conference, but there's really 4 sets of rules for HIPAA. So if you want to do this, patient choice in the US, this is what you need to do, right? You got to comply to security rules, you got to comply to privacy rules, and you comply to breach notification rules, and also a 4th set of rules called the HIPAA enforcement rules, which basically lists, what kind of fines and civil charges if you breach or you're not in compliance with any of those rules. But what it says here is that not only on the technology side, you need to have some pretty strong features in terms of data encryption, in terms of authentication layers, in terms of regular data integrity checks. You also need to implement organizational and administrative measures, which is training, which is have a HIPAA security and privacy officer. So it comes, as you see, as a great cost, and this is not something that's very easy to do. So the reward and the potential that we describe is certainly here, but the prerequisite is to make sure that anything in this page, and this is just an example of what we're going to do, needs to be fully complied with. So what does it do? I think if we go into a little bit more detail of what is this chaining of medical records for a patient mean? Well, first of all, again, the big concept is to make sure that the patient is empowered and has full control of his medical history. That's great. The second thing, because he's empowered, he's going to control and decide who is going to share with it and which part he's going to share with it. Maybe there's some parts you don't want to share for good reasons. And the other thing that blockchain will allow is obviously this audit trail capability of blockchain, which is to to trace and guarantee that anybody who accesses it, you can see it, and if there's some kind of misuse or tampering, well, you can see it immediately, right, with the technology. That's great. For a provider standpoint, doctor standpoint, for example, well, there's huge clinical benefits. Obviously, simple things like drug allergies, drug interactions, things like that, which kind of preconditions you have, especially in emergency situations. I think this is absolutely vital information, for a provider to take the right treatment decision. And what happens today is that, as we all did at some point of time, is that the doctor or the hospital or the nurse is going to ask you to fill a form, right, and put exactly this kind of information. What are your conditions? What's your current medication? What allergies? Et cetera, et cetera. So what we have here is actually providing this automatically in real time, and have the private time spent on treating the patient as opposed to gathering information to understand what's really going on. Okay, and obviously for the IT professional, it's great because it's impossible to tamper with, and it's a great also backup possibility because if you're being hit as it happened, was the WannaCry ransomware back in May, then this provides a pretty good backup information for not all the medical records, but the essential ones. So that's also very interesting. Okay, so what did we do? So in our prototype, we did this at a scaled down way, and what we did here is that we lit up like 5 nodes. Of course, we can light up much more. It's just a question of paying for them on Microsoft Azure, Ethereum. And we simulated 3 care centers, 1 hospital, 1 rehab center, 1 family practice, and we ingested, right, those bits and pieces of medical records within each one of those care centers, and then reconstructed this into a patient medical history, so the patient can see his medical history, and the patient can grant access to a certain number of doctors, providers, to the medical history or parts of it. Okay, so that's what we did. Now, one of the use case that we did is that we took a fictitious patient, Beth Davis, for good reasons. Today we're not HIPAA compliant. All the work I described is, in the previous slide, we need to do so. We can only work on fictitious data here. So imagine this patient that gets admitted in the hospital for a broken elbow, gets all kinds of tests, X-ray, surgery, gets some medication because she falls sick, and then she gets discharged on 1 week later, goes to a rehab center, takes some rest, gets some other treatments there, and then is discharged, goes back to home, and then visits her family doctor for a checkup. Okay, so what happens in terms of your medical records here is that one possibility is that each one of those care centers, the hospital, the rehab center, and the family doctor will, when you're being released, when you're being discharged, will issue you what is called a continuity of care document. So this is a standard, this is an HL7 standard that summarizes basically your encounters, treatments, medications, and all kinds of procedures you received at the hospital. Okay, so this is how it looks like, and you can see the complexity of these kind of documents. It's an XML document. So let me try now to switch. So this is how it looks like. This is a continuity of care document, and you can see it's an XML format. And there's a set of templates actually that forces, if you want, the kind of information that's being put in the XML file. You have a header here, which contains all the information on the patient. So this is, so it's not easy to read. Okay, there we go. So this is Bess Davis as the patient. She's born on July 14th, I'm sorry, 1945. That's her address. Then you have some information on the doctor. This is interesting. This is the EMR system, the electronic medical record system from the hospital who produced this continuity of care document. So this is an EPIC system, version 8.3. And then you have really the clinical information in terms of components here. So you're going to have, or sections rather, you're going to have an allergy section, a medication section, a procedure sections. And there's two parts in each section. There's one part which is called the human readable part, which I'm highlighting here, which is really free format. So this is an XML table here, and you can read, okay, well, she's clearly allergic to penicillin and to aspirin. And then you have a second part of the section which is coded, meaning that it's not supposed to be read by you and me, and certainly not during this talk. But you can see here, for those who like this, it's code information in the sense that what is being described in the human readable section is actually being detailed in the second section, which is, there's a code here which is called, if you take a look at the SNOMED, then the condition or the allergy rather she's subject to is coded 4195, etc. Okay, so you can see here, well, yeah, we can use this, right? We can use this. We can extract this code. We can extract the standard, and we can put this into standard identification, and we could put this into blockchain, right? So this is what we did. And going back to the presentations, so what we did here is that, so here's our CCD here, and we just injected bits and pieces, so relevant fields, if you want, from the CCDs into solidity contract, which is the data structure that's being described in blockchain. And so here I'm being logged on to my actually this is our team's development environment. So this is Theorem IDE on Cloud9. So it looks familiar to many of you, I'm sure. So this is how it works. So for example, this is the patient registry contract. Okay, so we define a struct, which is the first name, the middle name, last name of the patient, some personal information, identifiers, things like that. And then we define, some functions on which you can add some information. You can, add bits and pieces, right? And then what we do is that using the Web3 API, building some Node.js application bits and modules where we're gonna compile here the same patient registry contract here, output the bytecode in the API, as you can see here. This is the contract address. And then have some functions where you can basically add, right, using your Node.js application, some data, right? So for example, Beth Davis, we're gonna through this add patient info.js add her personal information from the CCD into the blockchain. Okay, so this is how basically it works. So moving forward. So I think I described kind of this is the flow. Okay, so this is how it looks like in terms of the patient output, right? And by the way, you can log on the website and there's some more details on this, but this is how it looks like. So once you retrieve the 3 CCDAs, so the 3 care centers, we had the hospital here, then we had the rehab center, then we have the family practice on the right side of the screen, So this gives a timeline. This gives this consolidation of the medical history, which is so hard to do because of the fragmentation issue and that we discussed earlier. And then, you know, you can have your medications, your problems, again, across different care centers, and you have drill down capabilities. And this is information that's very, very valuable, not only for the patient, but again, for the doctor, right? Because he can have in one snapshot, literally very quickly, okay, this is what's going on, and I feel comfortable, you know, therefore going with option A or option B or option C in terms of treatment. Okay, so obviously, you know, one of the things that you know, you learn when you develop this kind of prototype is that blockchain, you know, has pretty, you know, has limitations. So Ethereum specifically here, you know, has limitations in terms of the size of transaction or the size of data you can insert into transactions and you can mine into a block. And we had to actually to tweak, you know, the architecture quite a bit, because initially the idea was to let's try to put, you know, most of the CCD information into one transaction. Okay, and we found out that you know, the mining time was a little slow, was not great. So we had to tweak the architecture in terms of you know, cutting the CCD in different pieces. So for example, here in this example, you know, we cut it in 3, right? So that we restrict, if you want, we kind of minimize a little bit, you know, the amount of data that we're going to put in the transaction, and this kind of optimizes a little bit the performance. But it's hard to determine if we got the best architecture. I don't think so, because it's hard to predict. You know, if you cut it this way, then the mining time is going to be that, and it's hard to correlate. So we're still, you know, doing a lot of work on this. But this is one of the big learnings here, that you know, you need to be very actually careful of what kind of information you want to put into blockchain, because obviously you cannot put everything in there. Okay, so let me again discuss some of the learnings here. The first one has nothing to do with blockchain. So it's called you know, it's what's happening out there is that even though it's a standard, you know, called CCDA, the clinical document architecture, and it's fully documented. It's a 950-page, you know, standard documentation. You know, the way it's being implemented across the different EMRs, so people like Epic, Cerner, Allscripts, is actually very variable, right? So it's not very clean, if you want, and sometimes, you know, it's outright not complying for the standard. So one of the learnings here, and those of you who work in this area know this very well, is that this is going to be very expensive, you know, to kind of ingest all kinds of formats of CCDs. And then CCD is just one subset of HL7. There's other standards like FHIR, you know, which is the latest one. So actually, one of the biggest expense that we're going to incur in developing the you know, the GA version of Patient Truth is really going to be interfacing with all these different types and flavors and non-conformance of HL7, you know, input documents. Okay, so there's ways of doing this easier, like partnering with people who do this for a living, which, you know, we'll do. But still, the expense here is very high. Now, performance, I think I just discussed. This is a difficult issue because, of course, there's inherent limitations into a blockchain. So you cannot put, you know, a scan in blockchain, right? You cannot put, you know, megabytes of information, right, into a transaction blockchain. But I think what's even harder to figure out is the predictability of the performance, right? So meaning that if we do this in the architecture or this size of transaction, what happens to the mining time? This is very hard to predict. And there, as you know, there's very few tools in terms of systems management in Ethereum, you know, to kind of help us figure some kind of capacity planning or predictable capacity planning, right? So we got to do some more exploration here on, you know, what do we do next? Because obviously the idea for Patient Truth is to scale to millions of patients. And then the big problem in the healthcare industry is this issue of you know, patient identifier is pretty much proprietary to each of the care centers. So if you go to one hospital, you're going to identify 1, 2, 3, 4, 5. You could do a second hospital, it's going to be A, B, C, D, E. A third one is going to be something else, right? So there's no unique identifier. In some countries they have like social security number, but most countries they don't. And therefore it's just very hard to figure out, okay, this is patient Robert Chu, so let's, get all of his medical records and put this into blockchain. Well, the problem is that we don't know what they are, right? Because you're being identified differently in each one of the healthcare EMR systems. So we need to have some kind of a driving force, to kind of understand, where the medical records are, and the only person who really knows for sure is the patient. So we're going to, apply. I don't know if it's innovation, but in terms of business model, a token, right, that's linked to our patient truth solution, and we're basically going to reward patients with tokens as they go and do the tedious task of asking their different care centers for their CCDAs, and then putting those in the blockchain. There needs to be an incentive for a patient to do this, because it's not always easy to do so, right? And if you don't provide this incentive, then it's just very hard to to have patient adoption. Different people like Microsoft or Apple have tried different, similar concept, right? I think it's called Health Vault or whatever, and it didn't really take off, didn't really scale, because nobody was really incented, to gather the data in there, right? And I'm sure technically it was a great solution. So this is something that we need to think about beyond the technology also. Okay, before we take some questions, there are some, because healthcare is very specific, I think there's probably some misconceptions out there, when I hear some people or read some things, around healthcare and blockchain. I think one of the first one we need to be very clear is that blockchain is not going to replace EMR systems. Sometimes you read that, well, we're going to put all the, imaging systems and all the prescriptions, test results, everything into blockchain, and then, basically it's going to replace Epic or Cerner or these people. I think it's not going to happen just because of this, size of information restriction, right? Just because of this, right? And the other thing is that EMRs, they have a very specific function. It's actually clinical decision making. Okay, it's not just only gathering data. It's great, they need data to do so, but it's really to help the doctor, to decide for the best treatment option or the best medication, or to do this kind of test or this kind of surgery. And we'll always need EMR systems. So the right thing to do is to interface with those guys rather than try to replace them. I think that's pretty important. The other thing also you can see sometimes that, well, blockchain will solve this unique patient ID issue. I mean, this use case of connecting all your medical records into a single, consistent medical history is pretty common. It's out there. But again, as I said, the difficult thing is, where are your medical records, right? And having a technical solve with blockchain, I think is not going to happen, because, well, first of all, the technology that could solve this is more around master data management and fuzzy logic matching or some kind of artificial intelligence. So if you want to write this into a blockchain smart contract, I think it's just going to be very, very hard. And even with those technologies, the matching ratio you obtain is typically 80%, and you got to do the 20% of unsolved matching. So we don't know if this is the same patient kind of thing. You got to do it manual. You got to call the hospital, or you got to ask the patient. So it's not going to be a technical solve. It's certainly not going to be blockchain. Maybe some other technology. So we got to find something else to solve this patient ID issue, which is a real issue, but it's not going to be blockchain. The other thing I read recently, an article, and for your reference, I had on CoinDesk, I had the link, is that, well, because of this HIPAA compliant thing is so difficult in the US, and it's going to be a huge expense, right? As I mentioned, well, we're gonna do this outside of the US, and I think, well, guys, it's not easier outside the US. As a matter of fact, I think it's harder. So the other link is a short article comparing the European HIPAA, which is called GDPR. And you're going to see there's gives and takes, but overall, it's the same kind of notions. We need patient consent. We need, encryption. We need, administrative and organizational safeguards and things like that. So it's not going to be easy outside the U.S. And certainly the other thing is that, well, healthcare is not a global industry. Healthcare is a country industry. The regulation is country specific. The people who weigh in healthcare are people belonging to the country. So if you're not familiar with the country, then it's actually going to be harder than going, to a foreign country than your home country. So I don't think I think actually it's harder outside of the U.S. And then the other thing that I also saw is that, well, if you develop this kind of application, patient flows, you need FDA approval. So this is I think this is a big misconception. No, you don't need FDA approval. You only need FDA approval for like a mobile medical application, if the mobile and medical applications is directly tied to some kind of medical device, right, which is subject to FDA approval, or some kind of clinical advice linked to a medical device, okay? If you do just gathering of personal information, health information, it does not apply. And, you know, and if you just take a look at the FDA website, it says clearly FDA mobile medical app policy does not apply to mobile app development, okay? So, and by the way, why would you seek for FDA approval, which takes a lot of time, you know, when you should just release the product out there as quickly as possible, like in any technology business. Anyways, so just to tell you that there's a tremendous potential for sure, right? For all these good reasons, and it's well documented, I think. But it's a complex industry. Just take a look at HIPAA. And I think in this case, you know, hands-on industry experience matters a lot, because this is very hard to do if you never did it, very clearly. And healthcare is country-specific, so I think it's better to, you know, focus on each one's home country, you know, get this right, and then, you know, go to the next one. It's not rebuilding from scratch, but it's rebuilding 80% of it, right? And again, you need a local on-the-ground experience because the regulation is country-specific, and you know, the relationships you need to have, right, to be successful, you know, is also country specific. So this is also, it's at the end of the day, business-wise, additional cost, right? And then being a little bit old-fashioned, I think product matters a lot. So we have to remember that, you know, it's still an emerging technology. You know, we talked about the scalability, the predictability, systems management aspects, the limitations. And I think it's very important that each one of us, you know, who work in healthcare and blockchain, you know, we have to share as much as possible our learnings, what to do, what, you know, what works, what doesn't work, kind of thing. And you know, we're going to share the you know, the code of the prototype. So just show you a very, very short snippet, but it's going to be shared again of next week. And I think, you know, obviously I've been trying to see in GitHub, is there anything out there? And it seems to be confirmed by this article that you know, nobody's really showing anything, claiming they have something, but I really encourage, you know, all of my colleagues here to come forward, and this is a great forum, you know, to do so, to share, you know, as much as possible so that we can learn, because there are some true challenges, you know, in terms of scaling this technology. So I think that's it for the talk. Don't hesitate to you know, to go on the website, drop me an email. It's rchu@enblima.com. I should have put this on the slides. And then if you want to take a look at the code, just register on this website, and happy to continue discussion and the dialogue and sharing and learning that you know, we gathered through this prototype. So thank you. And I think now we can take some questions. Okay, so let me see. Okay, there's a first question, says from Alex, why are you building this on Ethereum? You don't really need a full trustless blockchain, and your product blockchain scalability with a big bottleneck. Why not go with trust permission, which can handle? Well, I think you're exactly right. You're exactly right. I can tell you that the GA system, the one that's going to scale, is not going to be on Ethereum. And you know, we're looking typically for scalability and system manageability first and foremost. And you're absolutely right. I mean, Ethereum is a fabulously rich, functionally rich, you know, and it's very elegant code and can do, it's very powerful. But for the purpose of what we're trying to do on this first use case, it's just not going to scale, you know, to the millions of patients that we want. So this is a very good advice you're giving me, Alex. Okay, so a question from Moshe: what performance did you get in adding and retrieving data from the blockchain? Okay, so specifically here, and we'll share some very detailed, you know, measurement metrics we had out of the prototype. So for a complex CCDA, so the one that it showed you, the Beth Hospital CCDA, I think it's like 2,000 rows. It has lots of things. So we extract 62 fields out of it. So again, we restricted, right, the number of fields, and to put this in the blockchain. So end to end. So we extract the 62 fields, transform this into a JSON file, you know, put this into transaction, mine it. It takes typically 40 seconds. So I have to give you the configuration of the testnet, right? Obviously, our private testnet, but you know, even with putting a GPU, it's gonna be in seconds. You know, it's not gonna be in sub-seconds. Is basically a conclusion. So that's what we have here. And can you explain how the data structure representing patients is maintained? Well, the data structure, I think I showed you a little bit of the struct, right? You know, the patient information in the blockchain. So all this PHI, protected health information is the blockchain. So all the sensitive stuff as defined by HIPAA. name, surname, identifier, date of birth, things like that. This is the blockchain. And then how's it queried? Well, we use a not.js module, right, to query the blockchain, right, and fetch basically out of the blockchain the different data fields out of the patient. It's called patient registry, solidity contract, as we've seen. So that's how it works. But you can see the full description, how this works in our code when we publish it in GitHub. Are you familiar with the Enigma project, which lets you pull obfuscated data from different sources and perform computation to pull data? Yeah, we started to look at this. I'm not sure. Again, it's definitely interesting in terms of the concept that we can apply to the healthcare data. But I think what we're looking first and foremost is something that scales, and also the other aspect is scaling is one thing and performance is one thing, but it's predictability and manageability. Because at the end of the day, things will happen. The system is going to go down, or the performance is going to go down. And it's very hard when you don't have the right system admin and system planification tools. So that's more a focus here. But you're right. There's also other changes we're looking at, like IOTA and things like that. Okay, well, if there's not any more questions, thanks again for having me. Very happy to continue discussion. Just drop me an email, and happy to share some more learnings, and obviously also learn from the community. So thank you very much, and I wish you a wonderful remainder of the conference. Thank you.